Before I jump right back into building engines again, I want to exercise my selfish pride. Many of these things are rare implements of DSM destruction. These are original Mitsubishi service tools. This particular tool is the balance shaft bearing puller. I also have the balance shaft bearing driver. These are the kinds of things you can't buy from the dealer, the auto parts store, or off of a Snap-on truck. I've been scouting these things in the used market and snapping up all the DSM stuff that I can find. Yes, I'm that guy. Sorry if you were outbid. I was also lucky enough to find the cam seal installer. I'll be using this a lot in the coming weeks. Sure, I could use a socket and risk damaging a cam seal. I haven't done it yet, but that doesn't mean I won't. I've also made a few mistakes along the way. This particular mistake was an attempt to get the right knock sensor socket. Don't get this one. Slotted sockets let you install and remove electrical sensors, and I have no idea what sensor on any DSM uses a 27mm. This one wasn't a mistake. In fact, it was a huge win. Mitsubishi charges $175 for this tool. I got this thing for 16 bucks off of eBay, and it's identical to the Mitsubishi tool. But another useless to me Mitsubishi tool I accidentally picked up was this valve stem seal driver for the single overhead cam heads. I don't expect to do much of any work to those things in the near future. No offense to all the single overhead cam guys. I just own different stuff. I nearly left this one out. This plate has multiple uses. It works with the other balance shaft tools I just showed you. On the puller, this is the anvil that the nut and the big washer use to pull out the bearings against. On the bearing driver, it acts as a stopper to ensure perfect bearing installation depth. I also have several boxes of parts I ordered since the New Year's teardown video that I've been meaning to open. Just busy, man, what can I say? There are 2 sets of Viton seals for the Hyundai head. I also have a dowel pin and an oil pan washer floating around in there. In this box we've got the oil pickup, valve cover gasket set, and all the seals, plugs, gaskets, and bits I stole out of the GSX stockpile. The last box is full of parts I need for changes I'm making to the engine. You saw the water-cooled oil filter housing upgrade. It's been so long since I've seen the hard coolant line that I had to buy a new one for 50 bucks just to see what it looks like. Nothing new on the Hyundai. This crusty old rusty one looks like it'll work perfectly. Also in the box are all of the factory molded hoses for a 1G Turbo 4G63. Don't ever bother replacing just one of them. Replace all of them together if one goes bad. When you have one fail, you know it's time for the rest to give up the ghost. And if any one of these things fail, your engine will overheat and it will leave you stranded. This simplifies my efforts in finding the correct sizes, shapes, and kinds of hoses. Vacuum, fuel, and hydraulic and coolant hoses are all different kinds of hoses. The stuff they sell by the foot at the auto parts store is not a one-size-fits-all hose. Aside from the hoses, I picked up new crush washers, and I'm reusing all the banjo bolts, but it's time to put all this junk away because I need to move on to bigger and better things. Not even 24 hours had passed, and I got my parts back from the machine shop. I checked in with them the next Monday after lunch, and it was right there on the floor, bagged and tagged, ready to go. Everything I asked for to be done was done in exactly the way I asked for it. Pretty simple laundry list, though. And getting a radius cut valve job done, I knew it would chip away at the nice polished finish, just a little bit, but oh well. You can see the rough stuff next to the polished stuff where the valves are shrouded, and it goes with the territory on a radius cut valve job. But this fixes all the trouble I caused for myself on the seats in the porting video. These last 2 seats at the end were actually the first ones to get cut. It's where the machine got set up and the stopper set to repeat the exact same cut on every seat. You can tell this because they were lapped, and that shiny little line above the rough lapped surface shows where the valve contact patch was moved. The valves would be recessed a bit more because of this, but not by very much. I got several good comments from people asking why I didn't gasket match the head. The reason is because in most every case it's a mistake. Port matching is one thing, but gasket matching this thing is a disaster if you're using either stock manifold. Don't do it. It's true that when you slap a gasket on it that there's a ton of meat around the ports, and you see a dirty carbon build up as if the manifold is bigger than the head. Well, it's not. The ports on the manifold and the head are exactly the same size. The gasket's just smaller. The same amount of meat is on the manifold as well. You really don't want to remove very much material around the flange of a stock cast manifold because there's not much meat that you can grind off before it gets too thin and it'll crack from the heat. There's other casting inside the manifold that could benefit from having a little cleanup done and being smoothed out. But if you gasket match the head, you'll make a huge step that can't be fixed without finding some kind of manifold to fit your custom work. Don't let the carbon line trick you into hogging this one out. You just want the head and the manifold to line up and meet flush and true around the port. Perhaps slightly larger on the exhaust manifold side if you have to make something bigger, but they already do pretty well straight from the factory. Your goal is only to fix it if they got it wrong. I had them do a minimal cut on the deck because there was still a little bit of meat on it, and we hit the service limit indicators. These bullseye looking things on the deck tell you when you've gone too far. Both of these touch down except that there's 3 of them. I took a depth measurement on the third one and got a difference of 8 thousandths of an inch. And to tell you the truth, I can't bring myself to care about that. During one of the many times that this thing's been resurfaced, someone was a little bit off kilter. This is what these things normally look like on a stock head. They're usually about 40 to 45 thousandths of an inch deep on a virgin deck. When you machine these things flush with the deck, you're done. So that's as far as she's going. I took the measurements of this thing just to be sure, and yep, dickered. This thing had between 34 and 42 thousandths shaved off of it. That diagram, look at it. The combined service limit for both the head and the block is 8 thousandths of an inch. When you go 5 times past that limit, you should probably stop. I suppose I'm treating it a bit more like a suggestion. So that's what I'm putting together today. We're going to start with the valve stem seals, and you probably saw Stuart from Ballast Machine demonstrate the trusty old nut driver method. Well, you can do the same thing with the socket. I'm using a 3/8 inch 12-point socket, and it's a perfect fit for a DSM valve seal. In the 100 series videos, I reminded everyone to pick out the remnants of the old seals that are always left behind when you rip them off to install new ones. You have to do this. Installing a new seal over a groove with one of these things in there will result in a leaky seal. It's easy enough to pick them out, but really scrutinize every last one of the valve guides in this step. This is a stupid thing to have to take a head back apart for. This head was hot tanked, and all 16 of these little things are still here. Clear the valve guides of dust or debris before you install the seal. I'm just using a shorty extension and a deep weld socket here with light taps. You'll feel and hear the seal bottom out. Now repeat this step 15 more times. The reason I selected Viton seals over factory EPDM rubber seals is their thermal resistance. Viton can withstand peak operating temperatures of up to 600 degrees Fahrenheit or 315 degrees Celsius. The factory EPDM rubber seals have a peak operating temperature of 300 degrees Fahrenheit or 150 degrees Celsius. With the seals installed, it's time to put some valves in this thing. What I've got here is a set of factory Mitsubishi 2nd generation turbo eclipse valves. And aside from being cleaned up, they've got an extra little trick performed to help them flow better. I had a back cut performed, which is just a fancy way of saying that I have an extra 30-degree grind performed on the back of the valve right above the 45. It's a subtle change, but it yields big improvements on the airflow of an intake valve. It eliminates a rough edge on a choke point as air enters the combustion chamber. Lots of aftermarket intake valves come with this treatment, but a factory Mitsubishi intake valve does not have it. It's an easy and cheap trick to have performed. My favorite. If I didn't have this, I'd use 40-weight motor oil for head assembly, but I have this, so I'm using it. It's thick stuff. You know you have the right stuff when the air bubble on the top of the bottle goes away when you shake it and doesn't come back for several hours. I also like to use denatured alcohol on everything that gets installed because it removes film layers and dries residue free. I use coffee filters to wipe things clean and compressed air as a last step to remove whatever microfibers are left behind. When I bought the eyedropper for the motor oil drag race, it came with this dosage thingy. I think this is for children, but since I don't have any of those, it gets used for a completely different and unrelated purpose. This thing's amazing. It stands up by itself spill-free and holds just enough assembly lube to prep 8 valves without wasting my $18 a bottle assembly lube. It's just the right depth for the valve stems. It's a silly thing to be happy about, but it's the little things in life that really make it worth living. I clean each valve and dip it into the assembly lube. As you insert them into the head, do it while rotating them to spread the assembly lube around. The fresh new valve stem seals will do a pretty good job at holding the oiled valves into the head while you work. I don't know what else to say here, but repeat this process 15 more times. With all the valves inserted, now it's time to install springs and retainers. I have Jamie's valve spring compressor, which is by far the most efficient valve spring compressor I've ever used. You can't buy this thing anywhere off the shelf, it's homemade. I've been given permission to reverse engineer it, but that's not going to happen in this video. In this video, I'm just going to clean it and use it. Once the deck surface is spotless, I oil it to give it a little added protection for the deck surface. It self-centers by dropping in a pair of head bolts. There's nothing complicated about how this works. Just be careful not to drop the valves out of the head prior to the springs being installed. Before you begin, ensure that you've blown all foreign material out of the crankcase. I wrapped up the valve springs, keepers, and retainers during assembly. I asked the original builder where these things came from, and he didn't know. They could have been from anything, turbo, non-turbo, Hyundai, Mitsubishi, who knows. I decided that the springs were useless on this build, and therefore all I needed were the keepers out of this ice cube tray. I'll be installing a different set of used valve springs and retainers just to keep this build on its box of scraps theme. Probably one of the most disappointing things to occur during the head disassembly, and what led me to port and polish the head prior to delivering it to the machine shop, was the condition of the camshafts. The cam journals took a beating and gouging from the bearing material that flowed through the oil system. This head really wasn't well oiled because of the shallow teardrop we found. Couple that with the bearing chunks and they really didn't do too well. The reason it's disappointing is because of how these were 260 duration camshafts out of a Hyundai Sonata, and that extra 22 degrees of duration provided the same mean lumpy idle that you'd expect from many expensive aftermarket cams. But because the lobe separation was so far off, both had to be retarded no less than 4 degrees, 8 degrees on the intake side, and what that did to the cam angle sensor made that car difficult to start. I just need the cam gears off of these things because I'm not going to reuse these camshafts. I had a set of old school Crow dual valve springs sitting around from another engine that I blew up, and because they're used, they become an excellent Hyundai sleeper bonus multiplier. Nobody at the track will see these nice titanium retainers or expect this ugly 4-door Hyundai Elantra to have anything like this in it. I still have the rocker set from the GSX teardown. I can't pass up the opportunity to upgrade the 1G lifters to these used 3rd revision lifters that only have about 10,000 miles on them. You watch me clean this set up in the Cylinder Head 107 video. They're oiled and ready to go. I still haven't made up my mind about what to do with the Hyundai rocker arms. I'm sure I'll have it figured out by the end of this video. I hate to replace them when I have a spare cylinder head sitting around begging for a set. They're expensive to replace. We'll take a better look at them later because they get installed next to last. My current priorities involve cleaning up all of these retainers and finishing the valve spring installation. Many of you who followed my other videos have already figured out where this build is going already. Shh! Don't spoil it for everyone else. Because these valve springs, seats, and retainers were oiled and they rolled around in a cardboard box for the past 2 years, I want to completely degrease them and remove any of that cardboard fuzz. The fastest way to do that is with mineral spirits. It would take a lot more work to do this with denatured alcohol, and can't you see me? I'm apparently in a hurry. I demonstrated the effectiveness of mineral spirits and compressed air in my DIY parts washer video. These springs fit perfectly in a 2G 4G63 head without modification, and I'm not even going to bother seeing how they stack up on this one because 1G and 2G valve train geometry is exactly the same. That's not the best way to do it, but I'm confident that it will work in my case because I've used all these parts before. I'll only be doing one simple test that you haven't seen me do to determine if this valve train fits with my build. If you need more help with valve train geometry, watch my Cylinder Head 203 video. I'm using a flat blade screwdriver with a dab of multi-purpose grease to install the keepers into the holes on the retainers around the valves. It's important not to use a magnetized screwdriver or you'll be cursing a lot. The keepers won't stay on the valve stems. They'll keep coming out with the screwdriver. The grease works well to accurately place it there, and then it's like spreading butter to let go of it. You have to do 32 of these things, so get the hang of it. The retainers are cone-shaped with a ring around each one that fits into a groove on the valve stem. When you unload the spring pressure on the tapered keepers with a tapered hole on the retainer, it captures or keeps all 6 of these parts as an assembly, thus the name keeper. Another handy thing to have around when you're doing this is a magnet, so you can easily retrieve the ones you drop. They love to go flying whenever you get it wrong, or fall off the screwdriver if you can't get it to stick in place on your first attempt. The magnet just helps make life a little bit easier. If one of those keepers does manage to fly off, don't just grab another one and keep going or you'll never find it. Stop what you're doing and find it immediately. They love to get lost, and that's ironic for something called a keeper. If you replace it with a spare one, the last place you want the lost one to end up is binding in a valve spring or rattling around inside your crankcase. I really didn't want to end the video like this, and I actually took this job a whole lot further than just unboxings, parts hoarding, port matching, manifold discussion, munch cams, part selection, freshly machined parts, and installing a bunch of valve stem seals and valves. I'm ready to finish this thing. Unfortunately, I can't show you the rest of it here in this video for reasons that are completely outside of my control. And I don't want to keep any of you waiting any longer without an update, so here's this video. I have a major hurdle to clear, and news of this hurdle is in the description rather than in the video because the news is bound to change. Plus that, I'm trying to win. The videos that follow this will be much more focused and far better served as separate topics anyway. I hope that when June 2014 arrives, you're all having to dig to the bottom of the comments pile of one of my crusty old videos to figure out what I'm talking about. But since I can't see the future, thank you for your time and attention on this project and all of the positive feedback. Read the description for updates and stay tubed.